All right, our last order of business here in Chapter 9 deals with molecular compounds. Well, molecular compounds are compounds that are not ionically bonded. We've talked about ionic compounds. Makes complete sense that an ionic compound should be ionically bonded. A molecular compound is different. It's a covalent bond or a sharing of electrons. So you're not dealing with something losing an electron and another element gaining an electron, which is the basis of an ionic bond. You're talking about sharing of electrons. And so the sharing of electrons is because in order for the substance, the compound, to have stable electron configurations, they don't want to lose or gain. They want to share. One might need one, and the other one might need to keep both of them. But by sharing and bonding that way, they both have enough to be stable. So that's a sharing of a electron. Examples we might have is SO2 versus NaCl. If you look at SO2 on the periodic table, sulfur is number 16. It has a 2- charge. O on the periodic table, what's its charge going to be? 2- as well. Notice that if we have a 2- and a 2-, I don't care that you have two oxygens and we have, well, we got a whole bunch of minuses here. We don't have a balancing of charges. Versus when you look at sodium with chlorine, notice the 1+, 1-, we have the right amount of them. The positives and the negatives are canceling each other out. This, of course, is an ionic bonded substance versus a covalent bond, the sharing of electrons in this example. So with covalent bonded substances, with molecular compounds, you are not trying to balance charges. Don't try to do it, it's not going to happen. Now, another way of describing this is when we have two non-metals getting together. So if you have two non-metals getting together, then you are forming a molecular compound, okay? So the way that we name these are different. I'm going to put this up here as well. Two non-metals together, okay? Now naming it is different, okay? And the reason it's different is because it's not a loss or gain of electrons, or in other words, the positives and negatives balancing each other out. Then these things can form multiple compounds with the same two things getting together, okay? So because of that, and let me just show you another example real quick before I even name, CO, a big capital C and a lowercase o, and CO2, all right? CO is carbon and oxygen getting together, as is this one, as is, let's say, C2O5. All carbons and oxygens only, but obviously not getting together because of ionic bonding. So this would be a covalent bond. And so how would we name this and this and this? They're all legitimate compounds. We have to name them differently. So the way that we do that is by using prefixes. You use prefixes, and I'm going to give you the prefixes in just a moment, but you use prefixes on these molecular compounds. The first symbol is the same as the element name, and you don't use mono if there's only one. Okay, the first symbol is the same as the element's name, and you don't use mono if there's one. The second one, you always use the prefix. You're always going to use the prefix, and it always ends in I. Okay, and so what are those prefixes? Well, to take a look at those prefixes, I have them right here. 1 is mono, 2 is di, 3 is tri, 4 is tetra, penta, hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So these are your prefixes. So again, if we look at the example I had before, CO versus CO2. Now, the first symbol is the same as the element name, and we don't use mono if there's only one. So there's only one carbon here, so we're just going to call it carbon. The same with this one, carbon. Okay. The second one, in this case, the oxygens are the second one. You're always going to use a prefix. So in this case, we do need to use the mono. Monoxide. Carbon monoxide. Versus, we're always going to, here we have two. So dioxide. So carbon monoxide is CO. Carbon dioxide is CO2. Notice again, they are not getting together because of ionic bonded substances. I think I'd thrown up this as well, C2O5. Obviously, the first one has more than one, so we don't use the mono if there's only one, but we do use the prefix if there is more than one. So dicarbon. Notice we keep the whole name, carbon. And then pent or penta oxide. Now really, if we have two vowels getting together, we drop one. You could call it pentaoxide. I would be fine with that. But really, notice pent shows me the 5, and then oxygen, but we drop the ending and add "ide," as it says here. Okay? This SO is, again, covalently bonded. So this one would be sulfur dioxide versus sodium chloride. Notice no prefixes here at all. Yes, we do need a prefix because it is covalent. Okay? Now, how do you tell if it's covalent versus ionic? Well, you need to know a little bit about your periodic table. And let's see here. I think I'm going to blank out, but let me just go ahead and get to this last slide one more time here. And I'll have more room. Let me do this. Okay. So again, really kind of quickly here, if I look at my periodic table, here I am, periodic table. Okay. We want to take a look at that carbon family. Okay, or the right about here. Okay. There is a little stairway right down here. If both elements are in this right side, if they're both here, these are some non-metals. If they're both in here, then, and they're getting together, these will be covalently bonded. Okay? So you noticed a while ago we had SO2. Well, S and O are both in this area right here. Okay? Carbon and oxygen. Well, carbon and oxygen. Okay, so those are examples. When we have a substance getting together from over here and the right side, that's your ionic. Okay? No prefixes. Here we must use prefixes. Okay? So that's your difference. So let's take a look at quickly one example and compare them. Two things that look really close to each other. Na2O versus N2O. Now notice, and if I were to draw my periodic table again here, okay, Na is over here. O is over there. N is over here. And O, of course, is over here. My little red line, they're right here. In this case, on the left here, this is an ionic because we got a sodium getting together with an oxygen. No prefixes necessary. We have Na plus, O2 minus. That's why it's Na2O. So this one would be called sodium oxide. No prefixes. This one, on the other hand, they're both on this right side, nitrogen and oxygen. So we do need the prefixes. And you can take a look if you wanted to look at the charges. Notice that there's no way for the pluses and minuses to cancel. So therefore, this one would be called dichloroethane. nitrogen monoxide. Notice we do need prefixes because they were covalently bonded.